Alright, so here is the new thing and the last thing of the notes. Frustum is a pyramid or cone with the vertex sliced off. So it is a pyramid or cone with the vertex, which is just, the top of it, sliced off. So it's as though you took a pyramid or a cone and you just cut the end off of it. And here are some pictures of them. Here is one with a pyramid that the top has been sliced off, and then here is the one with the cone that's been chopped off. We are not going to be doing the lateral area with these. We are just going to be focusing on the volume. So I'm going to use this formula, and you'll have to work at memorizing it because it's a new one, and it has a parenthesis opening but not a closing, so I added that little parenthesis closing there. But the formula is 1/3 times the height, then in parentheses it's the sum of the bases plus the square root of the product of the bases. So what you need for this formula is the height and each area of the bases. So on this one here, the height is the perpendicular distance between the bases. It's important to know. B1 will be the area of the top, and B2 will be the area of the bottom. And so since this is a pyramid, it's a rectangular pyramid. We've got this 18 and 19 here, and we've got these measurements of 13 and 12. And they've given us the height of 8. So we're going to be just plugging in all this stuff here. So I'm going to start by finding B1, which is the top, which is just going to be 12 times 13. And so B1 will be 156 meters squared. B2, which is the bottom, is going to be 18 times 19, and 18 times 19 is 342 meters squared. So now we've got B1 and B2, and we were given the height of 8 meters. And so I'm going to be filling into this new formula, so I'm moving up where we can see it. The volume is going to be 1/3 times the height times base 1 plus base 2 plus the square root of their product. There we go. Okay, so it's easier if you don't multiply these together and you just use these to do your simplification for simplifying your root. So I broke down the 156 as what it was, for the rectangle was 12 and 13, so that I didn't have to think about it. I just went back to kind of how did I get the 156. The 12 is 4 and 3, and the 4 is 2 and 2, so I've got a pair of 2's, lonely 3 and lonely 13 right now. And then go to the 342. It was made of 18 and 19. 18 is 3 and 6 is 3 and 2. And so I've got a pair of 3's here. I've got a lonely 2. I had the lonely 3 here, the lonely 13, and the lonely 19. Just be very careful not to lose anything. So the 2 times the 3 will be out front, 6. And then 3 times 13 times 2 times 19 will be inside, which is not pretty, but there it is. And that is simplified as far as we could get it. And then the bases, these pieces, we can add those together, just kind of cleaning up our math here, which would give me 498. So that is our parentheses. And then we had out front 1/3 times 8. Now I didn't simplify that part because it wouldn't get nicer. And so the way that I worked this out was I distributed this 1/3 times 8 times each piece, or really you could think of it as 8/3, and then we distribute it. So the way I did this was I did 8 times 498 divided by 3, and I got 1328 right there. And then I am distributing over here, but remember you're only multiplying by the 6, that's the number out front. The root will stay exactly as it is. So 8 times 6 divided by 3 gives me 16, and then bring that root down because you didn't affect that root. And this is an exact answer, and it's the best we can get. We do want to be used to exact answers, so that's meters cubed. And that is the volume for that one. And then the very last one, because it is different, so I want to show you this one. A little bit tricky on this one is they didn't give us the height. And so I want you to notice that if we drop down an identical height, identical to this one here, it creates a rectangle. And the top of it is 3 meters, and so this part will be 3 meters. And since the whole thing there, that whole radius on the bottom was 6, this will also be 3 meters, although I know it doesn't look like it's drawn to scale very well. And so this creates a right triangle right here with a side of 3 and a hypotenuse of 5. If you know your triple 3, 4, 5, then you already know the height would be 4. If you don't know your triples, then of course do Pythagorean theorem. 3 squared plus x squared equals 5 squared, and then solve for x, and then you would get 4. So the height of this frustum is 4 meters. Now I need base 1 and base 2. Base 1 is the top circle, which is pi r squared. So pi times 3 squared is 9 pi. Base 2 is pi times 6 squared. Don't forget the radius was 6 there. That's 36 pi. So now I have both my bases and I have my height, and I can plug it into the formula. So it's 1/3 the height of 4, the sum of the bases, plus the square root of their product. Alright, there's 2 pi's in here, so the pi's make a pair of pi's, so pi will go out. So we've got a pair of pi's. 9 is 3 and 3, pair of 3's. 36 is 6 and 6, pair of 6's, and we've got our pair of pi's. So 3 times 6, 18, pair of pi's, so 18 pi out front. I just like saying pair of pi's. And then the 9 pi and the 36 pi can combine to be 45 pi. And then out front we still had 1/3 times 4. So just kind of working it a bit at a time for you. And so these can combine, 45 pi and 18 pi, those can easily combine to be 63 pi, since they both had pi, and then still 1/3 times 4 there. And so 1/3 times 4 times 63 gives me 84, and so it's 84 pi, don't leave your pi off, meters cubed, because it's volume. And that is our notes. I hope this video is not too long. Let's see.